Now, we could try factoring further. You could do that. I mean, the numerator, for instance, you can't factor any further, right? It's x minus a number. You can't factor this down any further. The denominator, it looks like we could, right? We would probably have to use the AC method. But remember, we're just trying to simplify here, right? Clearly, the numerator is just x minus 4. Well, this can only be simplified if x minus 4 is a factor of the denominator. So for us to be able to this is going to be simplified if x minus 4 is not a factor of the denominator. In other words, what am I trying to say? I'm trying to say that we have to determine if x minus 4 is a factor of this, the denominator. That's what I mean by when I said is x minus 4 a factor. We have to figure out, is x minus 4 a factor of this? Now, could you factor the denominator? You could. But you know what? We don't have to. By the factor theorem, it's enough to check if 4 is a factor. If 4, is a root of the polynomial. In other words, if we replace x by 4, do we get 0? As you can see here, we do. So by the factor theorem, we can see that x minus 4 is a factor. Okay, so it might have been confusing what I said. Let me say this again. We want to know if this is simplified. Well, you can see that since x minus 4 is in the numerator, it's enough to determine if x minus 4 is a factor, is a common factor, that is. If it's a factor of the denominator. Now, could you factor the denominator using the AC method? Yeah, you could do that. It's doable. It's a little involved, but it's not terrible. But by the factor theorem, we don't have to. Now, by the factor theorem, we don't have to. Well, if we replace x by 4, right? Plug in 4 for x in the denominator, we do get 0. If somehow we didn't, then we'd be done. But we do, so x minus 4 is a factor of this. Okay, so we're not quite done. Now, we could factor this directly, but let's just use synthetic division. Personally, if I had to use either synthetic division or the AC method, I would use synthetic division. Because we want to factor this. Since we know x minus 4 is a factor, to get the other one, we can just divide. So we're using synthetic division to determine the other factor of this. That's what I'm doing here. All right, so again, you list, this number goes here. The coefficients of your dividend go here. This number comes down. 4 times 3 is 12, right? Minus 11 plus 12 is 1. 4 times 1 is 4. Minus 4 plus 4 is 0. These are the coefficients of our quotient. This here is our remainder. So this confirms that the remainder is 0, and this is a factor of this. X minus 4, is a factor of this. And this is saying that the quotient is 3 times x plus 1. Remember, the quotient's always 1 degree less. So this was x squared, the quotient's degree 1. So altogether, we get this is 3x plus 1 times x minus 4. Plug it in, x minus 4, as you can see, cancel. These cancel, we're left with this. What's nice about this example I was trying to show you is you could factor the denominator, but since we already know a factor of it, we don't have to. We can just use synthetic division. And I don't know about you, but I think this looks easier than the AC method. Okay, let me just do this quickly. Usually with math, you have to look over it a few times before you fully understand it. At least that's how I was when I was an undergrad. Usually in class, things, the material didn't click with me initially. It took some time. So, but I really hope it made sense on some level. I mean, if it didn't, please ask me a question. I don't have office hours today, unfortunately, but if there's something you don't understand, please don't be afraid to ask me. If you don't ask me, then there's nothing I can do. I really want everyone to learn this stuff. Looks like most people are getting it, so I guess we're good. All right, all right. Let's keep going then, I guess. Okay. Okay, so basically, again, this was just trying to illustrate how we can use division, synthetic division, to determine if a rational expression is simplified or not. Right? We knew a factor of the denominator using the factor theorem. Then what we did was we divided to get the remaining factor. It's just like with integer. It's just like when you're factoring an integer, right? How do you get what's left over? You divide. All right. Speaking of dividing, here I'm going through how you actually multiply and how you divide rational expressions. This is actually how you do it. And again, I emailed you the notes, so you have the notes in front of you. Here also, I should say this, that we're implicitly assuming the denominators are never, we're assuming that x's such that the denominators are not 0. So we're working in the domain, in other words. So b of x is not 0, d of x is not 0, and because of this right here, c of x is also not 0. So theoretically, the only thing that could be 0 is